Hello everyone. In this video we are going to talk a little bit about significant figures, more preliminary math stuff. So here we go. Okay, we'll start by just saying that not many people like significant figures. It's just one of those things that you kind of have to do because the answers in the back of the book are all in significant figures, so you need to know how they get those values. So why do we have to do it? What is it? Significant figures is a way to express the certainty of your measurements. So in physics labs we'll be doing lots of measuring. My example here is centimeters. And so let's say I measure something in the lab and it's a centimeter long. Well, if I have a centimeter that goes down to the 100th of a centimeter, then I could express my measurement as 1.00 centimeters versus just saying 1 centimeter. And the language of science says that this is implying that I used a tool that was accurate down to that value. Versus over here, the 1 centimeter, well, that's not as accurate. So it gives us a sense of what we use to take the measurements with. And significant figures are all about zeros, so we'll start by looking at some of the possible zeros that we might come across. We've got leading zeros, and so in the number 0.1, this 0 is out in front. We would say that leading zeros are not significant. Captive zeros, 101 has a 0 in the middle of the number, and yeah, it's going to be a significant figure, always. And the one that's confusing are the trailing zeros. If I have a decimal here, like in the number 1.00, both of those zeros are considered significant. The reason is because there's a decimal point in this number. If I don't put a decimal point in the number and I write just the number 100, those two zeros are not significant. They're placeholders. And what I can do if I have the number 100 and I want to say, yeah, this is really accurate, and not just have, like in this number, that would only be one significant figure. I could write the number out in scientific notation. And so the number 100 in scientific notation is 1.00 times 10 to the second. And when I write it like that, there's no ambiguity. We can see that both of those zeros are definitely significant. And we'll be using scientific notation a lot in this class. So I'll do a little example with that after I'm done with significant figures. So what do you have to know here? Take-home point. When we do physics problems in this class, you can't have more significant figures in the answer than in the problem. So you look at the numbers you're given, find the number that has the least significant figures, and your answer must be rounded to that number of significant figures. So let's do an example with that. So let's say I have the number 18.1, the measurement, 18.1 centimeters times 12.345 centimeters. And we're going to figure out the area here in square centimeters. I look at both of these values, and I have to look at the one that has fewer sig figs. So here, there's no zeros, so that's easy. I have 3 significant figures. My answer, I shouldn't express more than 3. When I multiply those two together with my calculator, I get 223.445. And I can't express those. I need to round them to 3 sig figs. So the answer that you would get here would be just 223 square centimeters. So like I mentioned in the last video, make sure you write the units, square centimeters, and then box or circle your answer so I can follow your work. What about addition? 15.12 centimeters plus 7.1 centimeters. Addition's a little bit different. I look at the least significant decimal place. So what that means is I'm going to look at this number here. I'm only expressing certainty to one decimal place, the tenths value. Over here I've got it down to the 100ths value, so my answer, I shouldn't show more than 10th decimal place. So when I add these I get 22.22. So I want to round to the 10th decimal place, which will just be 22.2 centimeters. Now, a lot of problems you'll have multi-step calculations. Keep the digits in your calculator and then do the rounding at the end. And if you have to like erase your stuff and retype the number into the calculator, just make sure when you retype it in you keep at least a minimum of the 100th decimal place as you do multi-step calculations. Scientific notation. A number that we might see a lot in this class is the speed of light, or 3.0 times 10 to the 8th meters per second. What is that number actually when we write it out? Well, I start by writing the 3 down, and then I'm at the decimal point. The 8 here means how many placeholders do I have to the right of that decimal. So I would have 8. 1, 2, 3, 4, 5, 6, 7, 8. Write in your commas. So 3 times 10 to the 8th is 300 million meters per second. That's the speed of light. Pretty fast. What about if I have a really small number? Let's say it's 12.12 times 10 to the negative 9th. I just made that up. Let's call it grams. We'll be measuring in grams and meters and seconds in this class. Always, always, always. So when I write this out, I'm going to go write the number 12.12, and then to the left of the decimal point I'm going to go 9 places. So we have to count the 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Put the new decimal. Fill in the zeros. 1, 2, 3, 4, 5, 6, 7, 8. And there was one more there. 9. So we should have 9 places to the left of the decimal. Our number is 0.00000001212, and I would remove this decimal. There. In class, I will help you multiply and divide with scientific notation. I need to see that you guys can use your calculators to do that without making errors. And everyone's calculator is a little bit different, and I'll show you one of the easiest ways to do it. So make sure you jot down any questions you have from this video, and we'll talk about it in class. All right, goodbye.